Hello everyone, in this video we'll be solving problem 380, insert, delete and get random with O of 1 time complexity. The problem statement is to implement the randomized set class. In the class there is a default constructor which initializes the randomized set object. There's an insert method which accepts an integer as an input. The method should save the value in a set if it is not present and accordingly return true or false. There's a remove method which accepts integer as an input and it removes the item value from the collection. And depending on the value exists in the collection, this method should return true or false. And the last method is getRandom, which should return any random value from the collection. Another constraint for us is to implement all of these methods with an average of O of 1 time complexity. The problem statement is very straightforward. We just need to make sure that we are choosing the right data structure to solve it. Let's switch to whiteboard and discuss the solution. Instead of diving into the implementation, let's first discuss which data structure can help us meet the requirements. As there are three methods, we'll go through each of these methods and understand what would be the time complexity of a particular data structure if we were to use it in the solution. Starting with the basic list data structure. To insert any value, the runtime complexity is always O of 1 for a list. As we are also required to check if the element already exists, the time complexity will be O of n. The same goes for the remove method. We can remove any element from a list with O of 1 time complexity, but we need to also check if it exists, for which we will require O of n runtime complexity. For the getRandom method, as we can return any element in the collection, we can simply do a lookup based on the index of the element using some random object to return the output. So the time complexity here is going to be O of 1. As list does not meet the requirements of O of 1 time complexity for all of the methods, we can't use it. Let's think of a different approach. As we want to check if the element already exists when inserting or removing and return true or false, HashSet might be a good choice here. Let's try that out. As all of the elements in HashSet are always unique, when we call the insert method with a duplicate value, the add method will return true if it is unique or return false. And the time complexity is O of 1. Similar logic applies to the remove method where it can return true or false if the element exists or does not exist before removing it in O of 1 runtime complexity. GetRandom is tricky because HashSet does not offer any capability of returning a random value based on indexes. So we will have to implement our custom solution which may require a higher time complexity of O of n. With HashSet, we were able to meet the first two requirements and only the last one is not met. So we need to figure out a way of combining these two data structures to solve our problem efficiently. One thing we need to make sure is whenever the insert method is being called, we need to add that value to both the list collection as well as the HashSet collection. And do the same with remove method. We need to make sure both list and HashSet are in sync. I hope you are able to understand how we are using both of these data structures to solve the problem while meeting the requirements of O of 1 runtime complexity. Let's check out the corresponding implementation in Java. Here's the solution in Java. I start by initializing three variables. The first one is the list of numbers or integers. Then we have a map of type integer and integer, where key will be the value which we get as part of the input when calling the insert method, and the value will be the corresponding index when we add the same number to nums. The last variable is of type random, which will be helpful in generating a random number. All of these three variables are being initialized in the constructor. Then let's go to the insert method. Using the contains key method, we first validate if the value already exists in the map. If yes, then we return false. If it does not exist, then we add that to the indices map with value as the input and size of the nums list as its corresponding value. It will be useful when we implement the remove method, as we'll know at what index the value exists in the list. We then add the value to the list and then return true. In the remove method, we first check if the value exists in the indices map. If it does not exist, we return false. If we remove the element based on index from the list, all of the elements after this number will be shifted to the left by one space. It will be an issue because the indexes will not match the values that we have saved in the map. We can avoid that issue by swapping the last element in the list with the element that needs to be removed and only update its corresponding index in the map. After the swap and updating the corresponding index, all of the values in the indices map are still valid, and we can complete all of the operations in O of 1 time complexity. After swapping, we remove the element from both of the collections and return true. The last method is the getRandom, where we are using the random object to get the next int between 0 to nums.size. Whatever the value, we use the get operation to get the corresponding value from the nums list and return it. This code, when submitted on LeetCode, beats nearly 59% of the submissions in terms of runtime and nearly 44% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.